Hello class. So today we're going to take all the little pieces of little tools that we've learned over this the majority of this chapter, so adding, subtracting polynomials, multiplying them, factoring them, all of that stuff, and we're going to use all that stuff to actually solve polynomial equations now, okay? And this whole thing is based on what's called the zero product rule. Okay, so the zero product rule basically says that if you multiply two things, well, I guess I don't want an equal sign there, colon, okay. If you multiply two things together, a times b, to equal 0, okay, if you multiply any two things together equals 0, that means that either a has to be 0 or b has to be 0. One of the two has to be true, okay. So that's going to be the basis for everything that we do to solve these equations. Alright, so the steps to do this. If you have a polynomial in your equation, so if you have any equation with exponents in it, okay, what you're going to want to do is you're going to want to first get everything on the left side of the equation and leave 0 on the right, okay, then factor the left side, right, and when we factor it, then we're going to get something that looks a lot like this zero product rule with obviously probably more things involved in A and more things involved in B. Okay, now once you get set up like this, a times b equals 0, then you could set each of those factors, a and b, to 0, because either a has to equal 0 or b has to equal 0, and you can solve for both of them. So you have multiple answers for a lot of these. Okay, this note down here is just some terminology, so you're going to see it within your book and some examples. You'll just get a function, right, without a 0, so this is like y, right, equals ax squared plus bx equals c. So if you have two variables like this in your equation, they might just say find the zeros of that function. Okay, so to find the zeros of that function, you just take the y, or the f of x, set that equal to 0, and then we could follow the same exact steps here. Factor the sides, set each factor to 0, and solve. Okay, looks just like that. This is basically finding the x-intercepts, and I can show you how to do that on your calculator when we get to class. One final note here, multiple roots. So a lot of these problems will say identify double roots, identify triple roots, identify multiple roots. That's going to be roots that show up more than once. So if you do some factoring and x plus 1 squared is involved, right, then that's the x plus 1 is showing up twice in the answer. Okay, so it would be a double root. You'll see it in the examples. Okay, so start with a couple of really simple ones. We got to solve and identify double roots. Okay, so we've already got this factored for us for numbers 1 and 2, so we're just going to deal with how to finish off the problem here at the beginning. Okay, so once we've got this, we basically have, right, a times b equals 0. Okay, so because of that, we can set a equals 0 and set b equals 0 and solve for both. So we've got 2c minus 1 equals 0, and solve for c. Add the 1, divide by 2, so c is 1/2. And the second one, we've got c plus 4 squared equals 0. Okay, that squared isn't going to matter much because square root of 0 is 0. So c is just going to be -4. Okay, and then you want to make some note. You could star it. You could just put like dr for double root, whatever to signify that this -4 is a double root. So the answers here would be 1/2 and -4. Obviously, this is not an exponent, right? This is totally separate. It's just identifying that it's a double root. Maybe best put it in parentheses. That's probably the best way to do it. If you just, yeah, some parentheses there, tell me it's a double root, and you'll be good to go. Okay? Now, the second problem here. Once again, we've already got it set up like this, but we can do some more factoring. Okay? So we've started to factor, but we can continue to factor. You always want to go as far as you possibly can in factoring. Okay, so we can hopefully notice here that we have a difference of two squares, x squared minus 9, so this is going to be x plus 3 and x minus 3, all equals 0. So now we've got a times b times c equals 0. Once again, one of those three things has to equal 0. So we set them all equal to 0 and solve. So if x minus 2 squared equals 0, the squared isn't going to matter, square root of 0 is 0, and then you add the 2, and so x equals 2, that is a double root. Okay, x plus 3 equals 0, so x equals -3, or x minus 3 equals 0, so x equals +3. Those three are all answers to this question. So to give you a little bit of perspective of what this really means is if you put this equation in your calculator, right? But instead of having 0, you had y. So y equals, when your calculator had the y equals x minus 2 squared, or quantity squared, times x squared minus 9, or if you just had this equation, since they're the same. Right, if you hit enter and you went to look at that graph, you'd see that that graph would cross the x-axis at 2, -3, and 3. Okay, that's kind of a good application for this. If you'd like to try it out with a calculator before class, that'd be a good thing to help you check your answers. Number 3 here. Okay, so we've got y squared plus 7y equals 18. Now we're going to have to start actually working from the beginning and doing the factoring on our own. So you want to get everything to the left, set it equal to 0, so y squared plus 7y minus 18 equals 0. Okay, the next step from there is to do our factoring. Got y in there, y in here. Okay, now we need to do the factoring. We need to multiply to -18 and add to positive 7. So since it's going to be -18, you know you have 1 plus 1 minus, so plus and minus. Since 7, right, we know that things that multiply to 18 are 1 and 18, 9 and 2. 9 and 2 are going to make most sense, so you want to pick the bigger one to go with the positive number because we want 9 minus 2, not 2 minus 9. There's 9, there's the 2. Okay, so when you set both equal to 0, you have y plus 9 equals 0, y minus 2 equals 0, so y equals -9 or y equals 2. Those are the two answers. No double roots involved. Alright, let's do the final 3. A little bit more challenging factoring going on in these problems. So once again, here we got to get everything to the left. 3r squared. Oh, that's supposed to be a minus sign. Minus 10r minus 8 equals 0. Okay, so we got to factor this. We've got the 3r, we've got an r equals 0. Okay, they're both, we're going to have one positive, one negative, correct? Because you multiply to -8, but we need them to add to -10. Remember that the 3 is going to be involved in the adding portion. Okay, it's not going to be involved in the multiplying portion. Okay, so remember that when you're doing this. The 3 takes part, this a in front of the x squared, or variable squared, is a part of the adding, the middle term, but it's not part of the final. So we have to have a plus and a minus. We have to figure out where to put them. Okay, you think about things that that add to or multiply to 8. It's going to be 4 and 2 and 8 and 1. 4 and 2 is going to be the better option here. If you have -4 over here, once again, I'm just going to get it right in the first time because I've done this before, but if you guys get stuck, you always need to check your answers. It's okay to check your answers, get the wrong one, and then go back and figure out what the right one is. All right, so check it. We've got 3r squared. When you do the front, we've got, now you say it in the back. That's good. You just got to make sure the middle term's good. Minus 12 plus 2 gives us minus 10, so it works. Okay, so to finish this one up, set them both equal to 0. Okay, so r equals 4, or r equals -2/3. Good. Continuing on, we have 15y squared plus 1 equals 8y, so bring the 8y over. Okay, do some factoring. Alright, now this is a little bit more difficult to factor because the 15 could look in a lot of different ways. It could be 15 and 1, or it could be 3 and 5. Okay, so this one you have to probably use trial and error more and more. Luckily, this 1, we know we're going to have 1 and 1. So that's good. So we know we have 1, or plus 1. Oh, sorry, it's going to be minus 1. I apologize, I'm dumb. So a lot of people would mistake that, including me, obviously, and see the plus 1 here and say, oh, it's going to be +1, +1. But remember, that could be -1, -1. You always want to look at the sign of the middle term to figure out if you want to be adding to a positive or a negative. Okay. Now think about what factors of 15 are going to add up to -8. Well, you should be able to think about 3 and 5. So we've got 5y and 3y. Okay. Those are our two factors, and set them equal to 0. Okay, and we'll have y equals 1/5 or y equals 1/3. Both are good answers. And finally, last problem here. Okay, so since we have c minus 6 squared plus or equals c, right, you could subtract that c over, but you're still not going to be able to do any factoring. Okay, so instead what we're going to have to do is we have to expand our c minus 6 squared first, and then bring the c over, and then refactor it. Okay, I know it seems like a lot of work, but it's the only way to do this problem. So c squared minus 12c plus 36 equals c. All right, now we can subtract our c over. So we'll have c squared minus 13c plus 36 equals 0. And now we can do our factoring. We've got a c in both of them. Okay, going to have to both be negative because I have to multiply to positive 36 and subtract to 13. Okay, so the only two things that multiply to 36 and subtract to or I guess add up to 13 are going to be negative 9 and negative 4. Oh no, that's okay. So to finish this up, I've got c minus 9 equals 0, c minus 4 equals 0, c equals 9, c equals 4. Those are both solutions. Okay, so get to the zero product rule, set them equal to 0, and solve. Make sure you factor completely, and you should be good.